When you create regions, you may find a surface you intend to model is not entirely flat. In this example, there is a basement floor which has a drain. The floor has different slopes toward the drain which cannot be modeled with a single region. When you use a small picking radius and pick regions on this floor, you will create regions with a local orientation or the local slope. It will do this within the limits of the out-of-plane tolerance. Solve this by creating multiple patches at multiple locations on this floor to cover the entire extent. Merge the regions into a single patch. Use the Merge Regions tool. Already the regions have different slopes in accordance with the drain position. Select the largest region first, so the smaller ones are rotated or projected into its plane. Press Enter and the merging is done. Merge Regions works based on the selection sequence. The first selected region will determine the orientation of the merged region. This region is not accepted because the orientation of this region is more than 5 degrees from the first selected region. The software therefore prohibits the use of this region as the geometry would be too far off. Now run this again using all 3 regions. These 2 regions have been merged reasonably well. Undo. Change the selection sequence and use the other region as reference. Select this region first, the larger one second, and press Enter to merge. Rotating the large region into the plane of the smaller one leads to an unwanted slope and a large systematic deviation which is not acceptable. Keep in mind that merging regions may change the orientation and therefore the match of a region patch. A different way to model the floor would involve the use of a UCS. If you cannot pick a common region for the surface, you can select the orientation yourself and manually create a region. To continue, I will delete the regions. For a floor, use a horizontal UCS. In the UCS group, select Horizontal UCS. Now, pick a point location for the horizontal UCS. It can be placed at the lowest point by selecting the drain position or at the highest point depending on preference. Review the UCS to verify it is acceptable and if necessary, use the Edit Grip Points tool to move the UCS. With the grip point, drag it to a different position in the point cloud like the position of the drain. Use this horizontal UCS as a drawing canvas. Select Draw Region on UCS and sketch a new region on the UCS. Use a few clicks to roughly sketch the floor and press Enter to finalize the drawing. Hide the UCS and review the region which is now placed at the height of the drain. As a planar region, this is an abstraction that does not image the slope of the original floor. With this region, use Trim and Extend to form consistent corners and edges to the wall. This horizontal floor now represents the lowest point. As an alternative, generate a UCS with 3 clicks in the point cloud. For this, go to the UCS tools, select Click Based, and place 3 clicks to define location and orientation of the UCS. A similar situation can be encountered when dealing with long, skinny features. With these skinny features, use a small picking radius which may not capture the overall orientation. First, create a clipping box to isolate the beam. The clipping box is now toggled on. With the region picking settings, place picks on the beam section. The region will now propagate along its entire length. This needs more picks to cover the beam so they can merge later. After placing a number of picks, merge the regions. As reference region, use the largest region selected first, then the others, and press Enter to merge them. Recall with merging that the items are rotated into the reference plane of the first selection, so if the first item is badly oriented, the result will be as well. When using a small picking radius, this can happen fast. The orientation may be off and merging will multiply the effect. To prevent this, use a UCS to fix the orientation. There are different ways of working with the UCS, but first, delete the created regions. To define the orientation of the beam section, use a 3-click UCS to cover the overall orientation. Select the click-based UCS item for this. Place the 3 picks far away from each other to increase orientation robustness. Now we have a UCS which can act as a drawing canvas or a constraint for regions. There are different possibilities to proceed. One way is to simply draw a region from scratch. Points can be placed on the UCS to draw the boundary. Remember, the region does not need to be perfect. The exact outer boundaries can be fixed later using the Trim and Extend tool. Creating a rough sketch or outline for the beam face is enough. Again, press Enter to finalize the drawing. The second possibility is to use the UCS as a constraint. Select Create Region and set the constraint to Parallel. There is a visible UCS, so it would be picked up as a constraint. Every region which is now picked is parallel to the UCS. With a slightly increased out-of-plane tolerance, I can then place picks on the beam section and check the results. Then select the Merge Region tool to merge them. The regions are all parallel, but they may not be part of the same plane. So here again, the first selected region determines the reference plane. Pick the region which is largest, and then the subsequent ones. There's another way to create the beam region with a UCS. Make sure you have a properly placed UCS selected as parallel constraint. With a good subset, increase the out-of-plane tolerance. Here, you can also increase the picking radius. Then place this generous pick. Because of the parallel constraint, a properly oriented region is obtained. Because of the high tolerances, the region will have a large reach because it is more tolerant to deviations. The setting will also cover the entire beam section with a single pick.